Let's talk about the inquiry section of Unit 11. So we have a formula right here, and we know that it has 2 iron atoms, get your periodic table, kids, and 3 sulfurs. So there are 2 irons and 3 sulfurs. Now, you got to get out your periodic table. Find sulfur. Hit pause if you got it. Sulfur is in the -2 column. So this is a group 16 nonmetal. And look, we have 2 indents here, and it is a -2. Now, it took 2 irons to counteract 3 sulfurs. So what we've got here is we've got a something and a -2. Now, it took 3 of these to balance out that and 2 of those. So where is -2 going to meet up with something like this? It took 3 of these. What's this total charge? -6. So the total charge is -6. So what's the total charge got to be here? +6, because these always have to add to 0. The total charge at the end, when you're all done, everything is considered. So if this has got to be +6 and it took 2 of them, what's the charge of it? It's +3. So the irons are +3. So we will call that a +3 metal. There we go. Now, we already illustrated on paper that it's going to take 2 of these and 3 of those. And then we can test it, and look, they dock correctly. So what group is sulfur in? It's in 16. What is the charge? What charge of iron was required? Now, we took some work to figure that out, but it was +2. What's the complete name of this? Iron Roman number 2 sulfide. Sorry, the charge was 3, wasn't it? 3, there we go. What's the total number of electrons lost or gained? Now, the metals want to go positive, which means they're losing electrons, and it was 3 of them that the iron lost, right? 3 electrons are lost. Oh, the total was 6. And the total here was 6 gained. And what's the rule? That they must be equal. The number of electrons must be gained must be equal to the number of electrons lost. Now we're on transition metals, naming ions. Hit pause, go there. And this is scandium. Not that you should know that, but you keep looking around until you find it. And honestly, I kind of forget myself. And it's right next to calcium. So this is scandium, and the +3 there means we call it Roman 3. Now I'm on writing formulas 2, and here's one of the sample problems. They said it was scandium 3, you had a Roman 3, and I know that that means this is a +3. And then it said selenium, and I look on my periodic table, hit pause and find it. Selenium is under oxygen, so it is a -2. How many do we need? These numbers need to add to 0 when I am done. Where do 3 and 2 meet on the number line? They meet at 6. So let's make this turn into +6 and -6. Well, how many of those do I need to accomplish that? I need 2 of them. How many of these do I need to accomplish that? I need 3 of them. And very often on these, what we get is what I call the turn and flip. So take the charges and rotate them opposite, kitty corner. That doesn't always work. If you do that and you get a 2 and a 4, we need to simplify it. But a lot of times that works. And here we are in the website. So that would be scandium with a 2 and selenium with a 3. On another sample problem, they said vanadium Roman 2, and that means that it's vanadium with a +2, And then they just said chloride, but look on your periodic table, chloride is a -1. So these need to meet at some common type charge so that the answer is 0 when we're done. Well, that's going to need only one of these, but two of those. And here we are. So it's going to need one of those and two of that. Let's talk about the reading formulas #1, and here is a sample problem. So I have this formula, and I look at my periodic table, and I find out that selenium is under oxygen, which means it is a -2 charge. How many are there? There are 3 of them, which means that the total charge needs to be -6 because the 3 times a -2 is a -6. Now, when I get done, this had better match and be opposite. So that should be a +6 here. And how many irons were there in there? How many iron atoms? 2. So how many did I use? 2. What's the charge then? If 2 of them turned into 6, the charge was +3. So what's the name of this? Well, the positive goes first, so it's iron. And what was the charge? It turned out each was a 3, so Roman 3. And then we don't use the in part, we use ide, so selenide. Let's do another one. Now let's do a more complicated one. Okay, so sulfur is under oxygen, so it is a -2. I have 2 of them, so the total charge is -4. That means that this should be a +4 when I get done, and I know that I have 1 lead. Lead, remember, I know it doesn't look like lead, but it's from Latin, so it is. And if I have 1 that to accomplish +4, they each must have been 4. A +4 charge. So what is the name of this? It is lead, Roman 4, sulfide. Remember to get the ide ending. Here are 2 examples from reading formulas 2, and it told us there was nickel, just 1 nickel and 1 selenium. I look on my periodic table and find out that selenium is -2. I know that these need to equal 0 when I'm done, so this must have been a +2 all by itself because there is only 1 of them. And so the name is nickel. Remember, we decided it's +2, so Roman 2. And remember, we use the ide ending, so it's selenide. Then we have another example where they give us this. The oxygen is a -2, so I have 3 -2s. That means that this side is -6. This side needs to be +6 when I'm done. And I know I have 2 of them. So what was the charge on scandium? It was +3. So the name is scandium. We decided the charge is +3. And remember the ide ending, oxide. Now I'm on polyatomic ions reading formulas. This tells me that there are 3 berylliums, and this 2 multiplies into all of this, all of that. So there is not just 1 arsenic, there are 2 sets of all of this, which means we have 1 arsenic in one and then 1 arsenic in the other. So there are 2 total arsenics. Every set of this has 4 oxygens, but then we have 2 sets of it. So that's a set of 4 and then another set of 4. So there are 8 oxygens. And the name of this then is beryllium arsenate. Why don't we use a Roman numeral on beryllium? Because look at your periodic table, hit pause, go look at it. The charge is always +2. I shouldn't have to tell people that. They can go look it up. How many aluminums are there? Just the 1. How many bromines are there? 1 each in each set, but we have 3 sets of it. So that's a total of 3. Every set has 4 oxygens, but I have 3 sets. 3 sets of 4 is 12. Do I need to tell people the charge of aluminum, it's always +3? Hit pause, go look at your periodic table. I don't need to tell them that. I can just say it's aluminum and they can figure out that it's +3 because they should look at the periodic table. Now go look at your ion chart. And I'm pretty sure this is per bromate. Why? Because it has an extra oxygen. Regular bromate is BrO3, but I have BrO4, which makes it per bromate. Now I am on writing formulas 2, and they give me the name, lithium sulfite. So lithium, which I notice is a +1 on my periodic table, and look at your ion chart. Sulfate would be SO4 -2, but sulfite, look at the naming grid, would be 1 fewer oxygens. So this is SO3 -2. Lithium, I look on my periodic table, is +1. Sulfite is related to sulfate. Sulfate is SO4 -2, but this is sulfite. Look at your naming grid. So this would be 1 fewer oxygens than sulfate. So it is SO3 -2. Obviously, when I get done with all of this formula, the charges need to equal 0. We can kind of do that turn and flip. So there are 2 of these and 1 of that. Don't write a 1. You could do parentheses 1, I guess, but no one does. So it is lithium 2 and then sulfite. And let's go back. What is the formula? So lithium 2 SO3. Then we had the name ammonium chloride. Look on your ion chart. Ammonium is NH4 +1. Now I get a lot of kids saying, so this is +4. No, this whole thing is +1. Don't multiply this plus by the 4. NH4 as a group is +1. Look on your periodic table. Chloride is -1. These charges need to add to 0 when I'm done, but they already do. So we will leave it. So it is NH4 Cl.